An electrolytic cell is basically a galvanic cell with a negative electric potential. To use the example of copper and zinc, zinc reacts with copper ions to produce solid copper and zinc ions. So what's going on here is that copper pulls the electrons through the wire and it becomes negatively charged over here. And as a result, what happens is these copper ions have a positive charge. They come over, absorb the electrons, and become solid copper. Now these electrons, as they become absorbed, it's going to continue pulling more and more electrons, and the electrons are supplied from the solid zinc. Solid zinc is going to give up 2 electrons, become a zinc ion, and continue supplying these electrons. Electrolysis is the same reaction, but going in the opposite direction. Solid copper, zinc ions becoming solid zinc and copper ions. So the same thing, the direction of the electrons is reversed. Now the negative charges are building up over at the zinc end. In order to alleviate those charges, the zinc ions become solid zinc, become part of the zinc bar, absorb those electrons, and the electrons are going to keep flowing in this direction in order to continue this electron flow. Copper is going to give up 2 electrons and supply the electron chain. But in order for this to occur, since this is a spontaneous reaction, when this runs, I hook up a voltmeter, it's going to say 1.1 volts, or if we just look it up in the table. So therefore this would be minus 1.1 volts. In order for this to occur, we need to hook it up to a power source greater than 1.1 volts. And what this is going to do is just push the electrons through the wire in the opposite direction. This is spontaneous, this is non-spontaneous. And that's basically electrolysis. It is a galvanic cell, but running in the opposite direction. In order for this electrolytic cell to occur, energy needs to be added, or the electrons need to be pushed in the opposite direction, which requires energy. This is a spontaneous process.